Okay, so have you ever, I don't know, stared at a dried up coffee stain and just wondered how it makes those weird patterns?
Yeah, I've definitely been there.
Well, it turns out scientists do that too, but with salt.
It's true, and it's way more interesting than you might think.
Today's deep dive is all about this how dissolved salts, when they dry out, they make these unique fingerprints. The shapes are wild.
And it's not just about the visuals, though they are really cool. This research connects to so many fields, from chemistry and geology all the way to potential applications in space exploration.
Okay, so our main source for this deep dive is this scientific paper dense, I'm not going to lie, but fascinating. Basically, these researchers took 42 different salt solutions, tiny droplets of them, put them on glass slides, and just let them dry out.
It's like the most low-tech experiment ever.
Right. But then they photograph everything super detailed. So it's kind of like if you had a coffee table book, but instead of landscapes, it's all these amazing close-ups of salt stains.
And here's the kicker. They weren't just cataloging them. They wanted to see, could you actually identify what a salt is made of just by looking at that dried pattern?
Wait, like a fingerprint, but for salt.
Exactly, a salt fingerprint.
That's so cool. I gotta say, when I saw the pictures, I was blown away. Some of them are these delicate rings. Others look like crazy fractals. There's even one that looks exactly like a fried egg.
Yeah, that's ammonium nitrate.
Yeah.
And those patterns, they probably happen because of tiny differences in, when the crystallization starts within the drop, it's this chaotic beauty of how things self-organize in chemistry.
Okay, so we've established the patterns are awesome, but how'd they even analyze all that? It's not like they just eyeballed it, right?
Right, it was way more precise than that. They created this thing called a morphospace.
Morphospace. Sounds intense.
It sounds complicated, but think of it this way. If you had to describe a shape to someone, you'd probably talk about its size, how many holes it has, how stretched out it is, right?
Yeah, makes sense.
That's basically what they did with the salt patterns. But with numbers, they translated those visual things into data points.
So each pattern got a numerical code based on its shape.
Exactly, which meant they could then use all sorts of fancy math and algorithms to analyze it all way more powerfully. It's like teaching a computer to see the patterns like we do.
Okay, that makes sense. So did they find anything cool? Were there any surprises?
Tons of surprises. So by analyzing the morphospace, they could group the salts into families based on similar patterns. What's wild is these families, they didn't always match up with how we usually group salts by their chemical formulas.
So table salt could be the black sheep of the salt family.
Kinda. So sodium chloride, your basic table salt, its drying patterns were surprisingly similar to potassium chloride and bromide. But here's the curveball. They were totally different from the patterns made by other sodium salts.
Whoa, so even within the same chemical family, huge variations.
Exactly. It's like each salt has its own personality when it comes to drying.
That is so wild. Okay, but the big question, did their whole salt fingerprint idea actually work? Could they really ID a salt just from its pattern?
Yeah, it worked. It actually worked.
No way.
Yeah, and get this, with crazy high accuracy.
Seriously?
Seriously. And that was with a pretty small sample size, too. They even did this thing, like a blind test, where they threw in salts that weren't in the original analysis, to see if it could still ID them.
Oh, smart. Like a pop quiz for their salt fingerprint method.
Exactly. And it aced it. It was shockingly accurate, even predicted some of the ones that were most likely to get mixed up.
Okay, color me impressed. This is way more intense than I thought at first. It's not just, oh, this one looks swirly, must be salt X. They actually found a whole system here. But hold on, they didn't just stop at pure salts, did they?
You're way ahead of me.
Yeah.
That's where it gets even cooler. They started mixing the salts, making salt cocktails.
Okay, now I'm really interested. So what happens when you mix them? Do the patterns just blend together?
You'd think so, right? But no, not always. They found even changing the amounts of each salt in a mix, even a little bit, could completely change the pattern.
Whoa, really? So a dash more of this salt, a pinch less of that one, totally different look.
Totally. It was wild.
Mm.
And sometimes the mixture patterns, they weren't just like a mashup of the individual salts. They made totally new patterns, things they'd never seen before.
Get out! So it's like each salt has its own visual language, and when you mix them, they make a whole new dialect.
Perfect analogy. And just like with a recipe, even a little change can make a big difference. Like they found shifting the ratio of salts, even a tiny bit, Total pattern makeover.
That's mind-blowing. But okay, I gotta ask, why does any of this matter? Like, why should we care about these salt patterns beyond just how cool they look?
Right. It's not just about pretty pictures, although they are pretty great. This has huge implications for like how we identify stuff in the future. Imagine being able to spot hazardous materials instantly just from a photo.
Or like analyzing what's in Martian soil without lugging a whole lab up there.
Exactly. This is just the beginning. Think what we could do with like huge data sets and AI analyzing this stuff.
It's like that dried droplet isn't just a stain anymore.
Okay,
It's a
so,
clue, a
have you
secret
ever,
code.
I don't know,
So
stared
cool.
at a dried up coffee
But how
stain
they make
just
sure
wondered
this
how it
wasn't
makes
just
those
some
weird
fluke,
patterns?
Yeah, I've definitely been there.
speaking.
Well, it
So
turns
how do you
out
know these salt
scientists
patterns
do that
were legit,
too,
like
but with
scientifically
salt.
sound
It's true.
and all that?
And it's
They were
way more
super
interesting than you might
careful.
think. Like good scientists should be. Their setup was simple, just saltwater drops on glass, but they controlled everything else they could think of. Temperature, how humid it was, even the kind of glass they used.
So no fancy lab, just good old-fashioned being thorough.
Exactly. This wasn't like, oops, spilled some salt. Look at that pattern. They wanted to nail down exactly how a salt's makeup and its dried pattern are connected. That way, they knew their results weren't because of something else.
Makes sense. Now, what about the amount of salt water? They mess with that too, right? Bigger drop, bigger pattern, or what?
Great question. It gets to how these patterns even happen. See, when a drop dries, a bunch of stuff is going on. How fast it evaporates, how the liquid moves inside the drop, then the crystals forming. It's all connected, but not always in a simple way.
Okay, so bigger drop, longer to dry. Does that give the crystals more time to like grow and rearrange?
Exactly. And they did find some stuff scaled up. Like
Yeah.
the area the salt covered, yeah, bigger drop, bigger area, pretty straightforward. But other things, like how many separate little salt islands were in the pattern, that didn't change much past a certain size.
So it's like there's a point where more water is not changing the salt's basic language. It's just giving it a bigger canvas.
Love that. And that's what's so cool. This isn't just taking a picture of a dried drop. It's figuring out this dance between the salt, the water, how it all dries. So many factors.
Makes you wonder what other hidden patterns are out there just waiting. Maybe that dried up puddle on the sidewalk's not so boring after all.
Well, this has been mind-blowing. Thanks for the deep dive. I feel way smarter now. Until next time, everyone.